Hello class. So, I wanted to continue from where I left off for 7.3 regarding the unit circle. And the big thing I wanted to focus on is this idea that actually I was slightly misleading. It's not the unit circle. It's not. This unit's actually called trig functions. And the reason why I wanted to change that is some of you may know of trig and may have some bad experiences with trig, and I really want to state that trig functions aren't bad, they're actually your friends. Like a puppy. Oh, cute puppy. So this idea of using trig functions as actually being helpful is really good for your mathematical process. However, we also need to do a little bit more on knowing more of actually the unit circle. So we're going to focus on that. So for here, I have an XY grid with a typically denoted axes as such that this is positive, this is negative, this is positive, and that this is negative. So let's say we start at some point here along this x-axis. We can say that this is point O, this is your origin, and that we have that radius r. If this is your initial ray, we have any terminal ray with some angle theta will create a circular path. Now, again, circle's not great, whatever, we'll deal. More importantly, we can pick any point, let's say point P along this path, and say that this is point P and this is actually denoted as XY. And how do you find that? Well, we simply just drop this down, hit the x-axis, and then we bring it over back to the origin. So from O to P, which is your terminal ray, you have some angle theta to your standard position, which is your positive x-axis. In this case, we could actually also look at the sides and say that, well, the terminal ray was r, and your x and y can be just written as x and y. If we look just at that shape then, and I bring it over here, kind of like explode it a little bit, we get this rxy, and we have a right angle in here with angle theta here. This is a right triangle, and if you remember anything about right triangles, you might remember Pythagoras' theorem. So let's say I knew this point was 3, 4, right? If I knew this point was 3, 4, I would say that I can say that the 3 is here and the 4 is here. And how do I find r? Well, with Pythagorean's theorem, you can say that x squared plus y squared is equal to r squared, your hypotenuse. And in this case, 3 squared plus 4 squared equals r squared, and you're going to get r equaling 5. And again, how is this helpful and how does this relate? Well, remember we were just talking about trig functions in the last page. Trig functions! And functions, again, is this tool of saying that we have some input into a setup that is going to give us an output. So in this case, the output for these were sine theta is going to give us a ratio of the y position to the radius, and that cosine theta is going to give you a ratio of x position to the radius. So before going forward, we have to know a little bit more. Hope you've been following. Things that I want to mention. From here on in, I may refer to different regions more specifically as this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Notice I've been going counterclockwise this whole time? Yeah. So in this case, we are going counterclockwise again, doing 1, 2, 3, 4. So to talk a little bit more about these quadrants, we're going to refer to quadrant 1 here in this highlighted region, that if you note that any point picked, here, 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 it is going to be, or those points are going to have a positive x-coordinate and a positive y coordinate. So all points in this region are positive. So if we go to quadrant 2, we're going to look at here, this region, and you'll note that actually you have now still a positive y, but you also have something different here as a negative x. So that's what we have here. Undo. And if we continue going forward to say that quadrant 3 is going to have both of them being negative. So on and so forth, we got quadrant 4, and in this case, you should see that it is a positive x and a negative y. If you're struggling to understand these notations of signage for positive and negative, I really try to remind students to say, or look at and view them as going x or going along the x-axis in one direction, maybe to the right, or the other direction, maybe to the left. All about basically their opposites. Same thing with the y-axis. You have positive and negative. Well, this could be referring going upwards with that amount or going downwards in that amount. It's just opposites. Again, just your sign issues only denoting going in the positive y direction or the negative y direction. Not a big deal in terms of what things are positive or negative, just that they are opposite to each other. I could have made this red and green, green and blue, or something opposite in a way that they are just not the same. Alright, now let's try an example. So for this example here, point W is located at negative 3, 1 on an x and y grid. Find the sine theta and cosine theta for point W. Feel free to take a moment and take this pause and try and see if you can solve this problem. So let's get started. And I like to start off by again drawing this out and saying that negative 3, 1 is going to be located somewhere over here. That is my terminal ray, and I have some angle theta here. And notice which quadrant I'm in. I'm in quadrant 2 with negative 3, 1. That's important. We'll come back to that. And we want to refer to these two relationships of cosine theta and sine theta. And in this case, for sine theta, I'm going to use green to denote sine theta. We have the y over the radius. That's that proportion there. And then we have our cosine, and blue, cosine is going to be x over the radius. And what I like to do here is drop a line here to state that's going to be my y, and this is going to be my x. I like to label it a little bit more as well to say that this is going to be 1, or sorry, this should be negative 3. Oops, there we go. And this is going to be 1. Or where x comes before y in this case. But then we're left with this mystery radius. Well, you find that using your x squared plus y squared equals r squared. And you're going to get, in this case, negative 3 squared plus 1 squared equals r squared. 9 plus 1, and that's going to give you 10 equals r squared. So r is equal to square root of 10. So this is helpful for solving the next bit, which is just looking for sine theta. Note it is just looking for sine theta, not what the theta is equal to, but sine theta. So you're looking at plugging this in, just 1 over whatever r is. In this case, it's root 10. We can rationalize it and say this is going to be root 10 over 10, but still, they are the same answer. And if we look at this one here, cosine theta, again, not looking for the angle theta, we plug in our x, and this is important, to plug in the negative 3, not positive 3, over radical 10. And if you rationalize it, you're going to get negative 3 radical 10 over 10. And those are your two answers for this question. So I hope you enjoyed this video, and I look forward to seeing you next time.